So for question number one, this is the question. An object 1 is moving following the law, x1 of t equals 100 plus 5t, and object 2 is moving following the law, x2 of t equals 3 plus t squared. Question number 1, at what time object 2 and object 1 have the same x, meaning they are at the same position? Question 2, at what time the velocity of object 2 is equal to the velocity of object 1? Means when do they have the same speed, at what time? And third question, draw x1 of t, x2 of t, v1 of t, v2 of t, a1 of t, and a2 of t. So this is my solution. As we know that first object is moving, let's say following the law, x1 of t equals 100 plus 5t, and second object is moving following the law 3 plus t squared. So we can compare these two formulas to this one, the basic one, which is x of t equals x0, which is initial position, plus v0 times t, initial velocity plus times time, and plus half of acceleration times time square. So how we gonna compare the formulas? We know that x0 is on the first place, so now we just have to compare x0 here is this one for second object, and for the first object is right here. So that means that for the second object, x0, which is initial position, is 3 meters, which means that the second object starts moving from 3 meters. And for the first object, it is 100 meters. So the first object starts moving from 100 meters. Then moving to the next, we can find initial velocity. So initial velocity for object number 1 will be 5t, 5, since v0 times t, here we can see this v0, which is 5 times t, which is like t. And here we don't have it. So we don't have the initial velocity. It means that it equals 0, because if we have this, then we'll have 0 meters per second times t, and it's gonna give us 0. Like, if we multiply 0 by any number, we're still gonna get a 0. So now we can find the acceleration. So here for the first object, we don't have acceleration, which means that it equals 0 meter per second square. I forgot to put that. v0 equals 5 meters per second, and here v0 is just 0 meters per second. So for object number 2, our acceleration, again, if we're gonna compare formulas right here, we see that here we have 1. So if we do calculate this, 1 over 2 times a equals 1, we're gonna get a equals 2 meters per second. It means that second object is moving with an acceleration 2 meters per second squared. Using this, we can solve our first question, which asks at what time object 2 and object 1 have the same x, meaning that we just have to solve x1 of t equals x2 of t. We already have these equations, so we just plug them in. From here, we get this, and then since I'm not from here, I did it in my school a little bit differently. So here you have this formula, which is x equals minus b plus minus square root of b squared minus 4ac divided by 2a. So basically what I did this step first, which is right here. And the rest, this step, it was right here. I just, again, did it in 2 steps. At the end, when I solved this, let's say equation, I got 2 numbers. So I will get this number and this number. But since I have here 5 minus 20.3 divided by 2, it means that I will have a negative number. But we cannot have negative number here since it's time, and time cannot be less than 0. So I decided to solve only the first one, and it was equal to 12.65, which means that at 12.65 seconds, these 2 objects will be at the same position. So I put the answer right here. Moving to the next question, which is at what time the velocity of object 2 is equal to the velocity of object 1. So for this, we just have to, it's kind of the same thing we were trying to find in the first one, in the first question, but just now we compare the velocities. So we just do v of 1t equals v2 of t. And we already found here that for first object, v1 is v initial, right? Here means v initial. So we already found that v initial for the first object is 5 meters per second. So we plug it in here. But for the second object, we have to solve this equation now. Since we know that velocity is equal to acceleration times time, we just plug it in here. And solving for t, we get t equals 2.5 seconds. So at 2.5 seconds, these 2 objects will be at the same, will have the same velocity. Moving to the third question, we should draw 1, 2, 3, 4, 5, 6 graphs, which are right here. So for the first graph, we were supposed to draw x1 of t, which is, we had it as a given already. So 100 plus 5t. So I have 2 axes. For x-axis, I have time. And for the y-axis is x of t, meaning that how, like the distance of the object. So if we plug in 0, we just plug in the numbers. So let's say we plug in 0 here, then we get just 100. It means that at 0 seconds, object is already at 100 meters. If we plug in 1, we get 100 plus 5, which is 105. So let's say 1 is here, we're moving up, it's 105 right here. And just plug in numbers, so it's gonna go always up with the constant velocity, right? So for equation number 2, we already have this as given. So when we have here power of 2, it means that we will have a parabola. Parabola is this shape. So we can plug in 1 or minus 1, and we still will have like a positive number because of the square. So let's say we plug in 0, we are 3, so it means that the object starts moving at 3 when it's 0 seconds. When we plug in 1, let's say here, we'll get 4. If we plug in minus 1, we'll still get 4 since it's square root. So we get minus 1, let's say 4 here, and plus 1 for here, and etc. We can plug in 2, minus 2, and blah blah blah. So it's gonna go up here and up here. Moving to the third, we'll have v1 of t, which is 5 meters per second, and we found it right here. So object is moving always with the same speed. It means a constant. So x-axis is t as always, y-axis is v of t, which means velocity. So we know that velocity is always 5 meters per second, so it's going to be just a straight line. The speed is not changing, it's not going up and down, just going straight. Moving to the fourth graph, we know that the velocity for second object equals to t. We found it right here and we plugged in here also. So when we draw it again, plug in the points. At 0 we get 0. So at 0 seconds the speed of the second object is 0. The velocity. 1, if we plug in 1 we get 2. So it's like 1, let's see, here was 2, and etc. For these two graphs, they're kind of the same, they just have different accelerations. So first object, we can even see it here, it's always moving with the constant velocity, 5 meters per second. It means that the acceleration is 0, right? So we just draw a line right here. Since it's 0, it's not changing as well. For the second object, here we found that a equals 2 meters per second square. So we just draw this line, which means that every second acceleration will be 2 meters per second squared. So this is the solution for the question number 1.